So the SI unit of this potential difference is known as what? Volt, not watt, right? So in the previous lesson we talked about watt, but it is volt, right? So the electromotive force of a cell is equal to the potential difference between the terminals of the cell when electricity is not drawn from the cell, right? So electromotive force means the force that pushes these electrons, right? So as I said, this negative terminal is the one who pushes the electrons towards the conducting wire, right? To the conducting wire. So when it is not connected to a circuit, right? There is a potential difference between these two ends, right? Um, so the current is not going through the cell. So so that um, uh, actually the potential difference between the terminals of the cell. So potential difference. So there is a potential difference between these two terminals also, because you have a very high density of negative ions here, negative charges here, and very high amount of positive charges here. So there also you have a potential difference. So that is known as the electromotive force. So this is actually when it is not connected to a external circuit, when the cell is at rest, right? So that is the electromotive force, which the force that pushes these electrons once it is connected to a circuit. So when an electric current is drawn from a cell, so now it is connected to a external circuit, and a current is passing through the wire. So what happens? So an electric current is drawn from from the cell. So and the current also passes through the cell itself, right? So when the current is going like this, so it goes here and here, and it goes through this cell also. So there is a resistance. So resistance means there's a bit of blocking. So this is a block now. I mean, it's a traffic, because there's a barrier here. So there's a barrier. So you have to surpass. I mean, you have to overcome that barrier. So there's a little bit of resistance. Um, so now we have to look at how this I can tell you that the electric instrument, the electrical instrument that we not actually electrical, so it can be electrical as well when if it is digital. So or digital or the normal volt, we use the instrument called voltmeter to in order to measure the potential difference. And there's a difference in connecting this voltmeter to the circuit, not like the ammeter. So you have the cells like this. This is positive, and if it is negative, and you have the bulb here, right? So you have a switch. You can have a switch here, bulb, switch, batteries. The current flows from positive to negative end, the conventional current, right? So earlier we connected the ammeter to this circuit as to the same wire, right? But here we cannot do that, because if we connect voltmeter here, you cannot take a potential difference now, because you have connected these two wires to this is the potential at this place and potential at this place is the same thing, it's zero, right? You have to take two different places to measure the potential difference. So then you have to connect the wattmeter like this, right? So this is one end and this is one end. The difference between these two ends, right? The pressure, electric pressure differences between these two points will be measured by the wattmeter. Okay? So always remember that the wattmeter we have to connect the wattmeter parallel to the circuit, right? And the ammeter should be connected in series, right? Series means one after another. That means after the bulb you can place the ammeter, right? Or like this ammeter battery. Parallel means you have to take two ends. So the next part I will do next time. We have to learn about the Ohm's law, uh, Ohm's law, and then we have to plot a graph and the resistance. You have to calculate the resistance of the resistors, and you have to find the sum of the resistors, sum of the voltages, right? So a little bit of maths in that part. So I can finish the lesson next time. So I'll stop at this point for today.